And welcome back to the Game Engine series. I am PokeLego Dev, and if you've been following along so far, we've created our initial application in Zig, and we have a window up. And today is going to be a much more exciting episode. Be the biggest episode of the series so far because we're doing what is arguably the most important thing, and that's getting a triangle rendered. Obviously, we have a simple color on the screen, but we want a triangle, right? Like this is game engine graphics. Well, we're going to get that triangle on the screen. And if you stick to the end of the episode, I'm also going to show how to go from making just a single color triangle into a rainbow triangle. So make sure you stay tuned for that. And once again, I really appreciate everyone who's been watching the series. It's really motivating. This is my first series on YouTube, and I hope everyone's been enjoying it. And if at any times you have any questions, make sure to comment below. Very actively looking at them. We'll be happy to answer any questions you got. And right before we jump into the code, just a reminder that the code is down in the description. It's in the YT branch if you want to be following along exactly with the series. And also just a reminder, if you go to the code and be like, why is there so much? It's because I'm actively developing it. I'm trying to go as far ahead as I can because I'm doing it on Twitch. That link is also down in the description. And if I'm ever live, come say hi, come chat. You'll see where we are at with the game engine. And yeah, let's jump into the code. Okay, and we're back in the code. So just to recall what we did last time, we run the code, we have our red screen. So before we actually get into it, I am just going to turn this back into gray. Okay, so we have our gray screen. So again, I'm just going to get right into it. There's quite a bit of code to write here. So if you have any questions, drop them down in the comments. Happy to answer. And again, this isn't an OpenGL tutorial, so I'm just going to be writing the code. There's lots of great resources out there. I recommend checking out either the Churnos series or read the OpenGL book. That's free online. Yeah, so let's get into it. Okay, so first we're going to need our triangle data. So let's get our vertices. And it's going to be 3x3, F32s. You can also structure this to just be a single array of 9, but I just find this to be a little bit more readable. So these will just be the standard vertices for the triangle. This one 0.5, and this one will be 0, 0.5. Okay, so we have our vertices. Now we're going to have to create our vertex arrays, buffers, and we're not going to worry about indices right now. That can be added later, or probably even in the next episode potentially. But yeah, okay, so we just need our vertex array and vertex buffer right now. So let's make that 2, 0, and then do GL gen vertex arrays, be the first slot, and we'll bind it to that U32. And same thing with our vertex buffer, let's just create that exact same way. Gen buffers, this one, again, first slot, and bind it to that vertex buffer. Okay. So now we also want to create our shaders. So what we're going to do is there's a very easy way in Zig to just be able to embed a file. Let's do assets, shaders, and then we'll do, for now, vertex.glsl. Then we'll also create fragment.glsl. And while we're here, let's just write them out. So it'll be version 330 core layout. So this will be that what gets passed in here is those vertices, a position. Now let's write the main, and we're just going to GL position equals a vec4, and then we'll just take the vertex data. .c, and we won't modify the alpha. Okay, and that's our vertex shader. Now our fragment shader, version 330 core. And then out. So now we're getting that color, which will this will be the final color like of the triangle. So for now, let's just give it a nice kind of red color. Spec 4, and you can make this any color you want. This will be the color of your triangle. So play around with it once we get that triangle. Okay, and those are shaders. So heading back over here, let's start by getting the source data. So const vertex source, and this will be needed to be a specific type for glad. It'll be like this, and then we just do embed file, and then do assets shaders vertex, and yeah. So embed file basically just turns this into interpolated string. I find this easier because now we can already move the shader code to their own files, but it doesn't slow us down at all. It's very fast. We will eventually do proper reading of files when we fully go into shaders, but for now, this works great. So let's keep going. Const, so now we need the actual value. So GL create shader, and then we'll just do GL vertex shader. So we created the vertex shader. Now let's bind it to that source we just did. Shader source. Yes. Now first slot. Actually pass the data. And we don't care about the last one. Okay, and then let's compile that shader. Something that also I'm not going to do here, but we'll definitely add it and should be added, is just doing an error check if this compile fails. But again, just to get up and running quickly, we're going to skip it, but that is a challenge. If you can do that, that's awesome. So now we're going to do the exact same thing, but with our fragment shader. GL fragment shader, fs, and okay. So now we have both the shaders compiled. Now we'll create our actual shader program. gl.gl create program. And then let's attach those shaders to the program and then both shaders. Okay, great. So now we have to also link program, the program. Okay. And now that it's linked, we don't actually care about those first two shaders, so we can delete them. Delete shader fs and the fragment shader. So first we're going to bind our vertex array. Bind vertex array. And then also bind the buffer. GL array buffer to that vertex buffer we created earlier. And now we need to actually put the data inside of there. Buffer data, GL array buffer, size of F32. And then we have 9 vertices and just doing static draw. Need the snooze of capital O. Now let's put the vertex attribute pointer. Vertex trib pointer 0. We have 3 vertices. They are floats. And this is the amount of space they're taking. F32s. And then just pointer to 0 to that 0 slot. So there's no offsets right now. Then GL, and let's enable that. Attrib array. Oh, that's all right. GL, enable vertex attrib array. There we go. Okay, we're almost there. So now let's do GL use program, that program, GL.gl bind vertex array to our vertex array. And then let's actually do our draw calls. Our draw call. So we're just doing triangle. starting from 0 and drawing 3 triangles. So if we've done everything correctly, let's go run this. Okay. Oh, just one mistake up here. Let's try again. Okay, one other quick mistake. This was on line 23, or 73, I mean. Okay, so we have 0, 3, float. Oh, we forgot to say that it's not uniform. Try one more time. And there we go. We have our triangle. So one thing I'm also realizing, I believe we should be able to just bind the data ahead of time. And it should still work because it's not changing at all. And it does. So that's less code on the GPU every frame. I think even this code could probably also, because it's, again, it's not changing the layout of our data. Yep, and it's all still here. Okay. So yeah, so again, if you want to change the color, you can go into your fragment shader. But for anyone that's stayed this long, I'm going to show you how you can turn this triangle into a rainbow triangle. So let's get right into that, and then we'll wrap up the episode. Okay, so I'm going to start with the vertex shader. So first, we're going to have to create an out variable for our vertex position. Vertex position. And then what we're going to do in the fragment shader is make the color of the pixel to position on the screen. So vertex pos just equals the input position. So we're just passing through the layout into our fragment shader. So now we're going to need that in 3 vertex pos. Okay, and now we're going to use that inside of here. So the first one will be vertex pos .x plus 0.5. And then same thing, .y plus 0.5. And then you can play around with these numbers too. Just have fun with it. And then there is no z. So in order to kind of properly make this look good, that's why this last one is a little different. But again, play around with these values, see how it looks. And if we run it and did it correctly, there we go. We have our rainbow triangle. And if you have any questions, again, drop them down in the comments. And that's it for the episode. I hope you enjoyed. And again, what we did today, we got a triangle on the screen and made it a rainbow, which is, I'd say, a pretty fun thing to do. And I hope everyone is able to follow along and get there, because getting a triangle, that's arguably the hardest thing to do when you're first starting off in graphics. So good job. Give yourself a pat on the back. And what are we going to do next time? Well, the code right now, if you see, we're using GLFW everywhere. We're using OpenGL functions everywhere. It's all in one file, really. So I'm going to take some time, clean up the code next time, properly abstract shaders into their own struct, vertex buffers, vertex arrays, maybe even do window. That might have to be another episode in itself, because it's quite a bit of code. It's not hard. It's just abstracting what we already wrote. But I may either throw in how to do index buffers next episode as kind of a bonus to keep progressing, or I'll do a quick, shorter video in the meantime. And that's the video for today. Again, I really appreciate everyone who's watching. And if you could drop a like, subscribe, comment, anything you want. If you made this far, let's see, let's comment Zig Game Engine. If you made it this far, big shout out to all you. And yeah, it helps the algorithm, it helps me growing as a small creator. And I just appreciate all of you. But that's it, and have a great day.